All right, so the first problem on the warm-up is negative x to the fourth plus 3x squared minus 1. And you don't have to put the y equals in there, but you can, doesn't matter. So that's what the first graph looks like. When we draw the sketch on our paper, we're just drawing it really so we can do the labels for increasing and decreasing. So you don't have to have a super accurate sketch. That's why I didn't put graph there for you. So just a little sketch is fine, something like that. So domain, those are your x values, range is your y values. So if we look at the graph and we look from left to right, what do we notice? Left to right. So left to right. Both of the, but we have arrows, right? So what's our domain? Negative infinity to positive infinity. And at this point, we shouldn't have earbuds at all. We shouldn't have cell phones out at all. Right. And let's take that calculator down because I don't know why I would have it sitting like that. Oh, yeah, I'm sure it is. All right. The range. We're looking from down to up. So what does the very bottom of our graph look like? I'm still waiting for the calculators to come down. Thank you. All right, so the bottom of our graph is arrows. What do we write for that? Negative infinity. And then what about the top of our graph? Does the top of our graph go up forever? No, it stops. And so we're going to have to look at these points and see what number it stops at. So when I look at the graph, you can see that there's 2 points there. And so when we look at those points, we just want to make sure that the value is the same for each of those. And what do you guys notice? Yeah, the y coordinates of both are the same, 1.25 for each of those. And so for the range, we're just going to say 1.25 for the upper part of the range. And then when we write the range, are we going to put a bracket or a parenthesis? We're going to put a bracket because we stop right there at that number. And that's an actual point. I can touch it with my finger. Okay. When we do the increasing and the decreasing intervals, we got headphones out now. Thank you. Increasing and decreasing intervals. If we put our stick figure here and they start walking, are they walking uphill or downhill? They are walking uphill. They walk uphill until they hit the maximum. And then what do? Now they're walking downhill. They walk downhill until they hit the minimum. And then what do? Then they walk uphill. They walk uphill until they hit the maximum. And then what do? Then they walk downhill. When we answer increasing and decreasing intervals, are we using x values or y values? We're always using x values. Always, always. Okay, so this is an arrow. We're thinking in terms of left and right arrows since we're using x values. So this is a left arrow. And what do we use for a left arrow? Negative infinity. What do we use for a right arrow? Positive infinity. Okay. For this maximum, we're going to go and look at the maximum and the minimums. And we're going to look at the x and the y values there. So I can label each of those x values on my graph. So negative 1.225, positive 1.225 for the other maximum, and then 0 for the minimum in between. I'm going to label that on my picture. And then I can go through and list my increasing and decreasing intervals. So my first increasing interval is going to be what? Okay, so from negative infinity to negative 1.225, bracket or parenthesis? Parenthesis. Typo, right? And then we have another increasing interval. What do I put for this one? I'm going to use the 1.225, but what do I put first? 0. Okay, then I put 0, 1.225. And what do I put around these? Parentheses around both of these. Remember, for increasing and decreasing, you can put parentheses for every single answer. I'm going to put a U in between because I've got two answers and you have to have both of them to be right. If you don't have both of them, you're not going to be right. All right, the decreasing answer for the first one is what? Negative 1.225 and 0. Parentheses or brackets? Parentheses, okay. And then what's the other decreasing answer? 1.225 infinity. Okay, put parentheses around that, put a U in between. Okay. Now, if we look at the graph, we have two maximums right here at the top. We have two mountaintops. So for maximum, I'm going to put negative 1.225, comma 1.25. I'm also going to put 1.225, comma 1.25 because we've got two. And then for the minimum down here, we've got one minimum at 0, negative 1. Now, that minimum also happens to be a y-intercept. So for y-intercept, you can put 0, negative 1. And then we have a lot of x-intercepts. So we have negative 1.618, positive 1.618. There's two x-intercepts that are very similar. And then we also have these two x-intercepts right here. So negative 0.618 and positive 0.618. So four x-intercepts that are all very similar decimals. So negative 1.618, negative 0.618, positive 1.618, positive 0.618. Okay. End behavior is pretty simple. I'm going to draw my sketch again. The left arrow does what? Goes down. So what number do I write? Negative infinity. The right arrow does what? Goes down. So what do I write? Negative infinity for that one as well. All right, let's go through and graph the other one. So we have x to the third minus 3x squared minus 1. Looks like that. So I'm going to draw a little sketch. So if we're going to do the domain and the range, domain is x values, range is y values. So if I look at this little sketch, how far to the left does my graph go? How far to the right does my graph go? Left and right. Anybody? Yeah, goes forever to the left, forever to the left, forever to the right. So negative infinity, positive infinity, okay? How far down does my graph go? How far up does my graph go? Forever, forever. Okay. So I put my little stick figure right here and he starts walking. Which direction is he walking? He's walking uphill. Okay, he gets to the maximum and then where does he walk? Downhill. He gets to the minimum and there, where does he walk? Uphill. Okay. For increasing and decreasing intervals, do we use the x's or the y's? We use the x's. All right, so what x value is a left arrow? Negative infinity. What x value is a right arrow? Positive infinity. Okay, so let's look for this particular graph and see what x values are used for the max and the min. So the max is also the y-intercept. We're going to use an x value of 0. The min has an x value of 2. Okay, so for the first increasing interval, what should I put? For the first increasing interval, what should I put? Okay, negative infinity 0. And what should I put around it? Parentheses. For the second increasing interval, what should I put? To infinity. And what should I put around it? Parentheses. And what should I put in between two answers? I should put a U. You need both answers to be correct. You can't just have one. For the decreasing answer, what should I put? 0 to 2. And what should I put around there? Parentheses. Okay. The maximum, let's go ahead and write down the actual points for the max and the min. So the max is 0, -1. The min is 2, -5. That point for the maximum is actually also the y-intercept. So I'm going to write 0, -1 for the y-intercept as well. And then up here we have the x-intercept, 3.104. All right. Now we need to do the end behavior. Okay, so what is happening with our left arrow? Our left arrow goes down. So I'm saying the left arrow goes down. How do I write that it goes down? Negative infinity. What's happening to the right arrow? Goes up. So the right arrow, I'm going to say it goes up. So what do I write? Positive infinity. All right. Get your name on your warm up and get it turned in. It says we have a water balloon that's catapulted into the air so that the height in meters after t seconds is modeled by this equation. So we're going to go ahead and draw kind of a picture of what happens when you catapult a water balloon. So your catapult, it could be on the ground, it could be off the ground, but you're going to have like a little water balloon and it's going to go like into the air and then fall down to the ground. So it's going to look like something like this. And then the water balloon hits the ground and it that's the splat of the water. I'm not very good at drawing pictures. Splats on the ground. They're telling you that this is the equation that we have, and when we plug it into Desmos, it's not going to be plugged in as an H and a T. When we plug it into Desmos, Desmos only does X's and Y's, and so this is probably the only time I'm going to let you change variables in a problem, just because Desmos will not let you plug it in this way. So this is going to be the Y coordinate. And then these are all going to be X's when we plug it into Desmos. So we're going to say Y equals -4.9 x squared plus 27x plus 2.4. That's what it's going to be when we plug it into Desmos. And they said the height in meters after t seconds. So the t is going to stand for x. X is going to be seconds. And the h was height in meters, and so y is in meters. So that means that this part, the x-axis, this is going to be your time. How much time has passed in the problem. And this side right here is going to be your height. That's how high off the ground the water balloon is. And then whenever we look at Desmos and we get an X and a Y point, the X point is going to be telling us what the time is. The X part of the point, the Y part of the point is going to be telling us what our height is. The X is going to be in seconds. And the Y is going to be in meters. And I like to write that right at the beginning of a problem because it helps me to know when I do each question, if I'm looking for a Y coordinate or if I'm looking for an X coordinate, like which one the answer is. And then that helps me figure out, okay, which information did they give me then? So that can be really helpful. So This over here where we launched the water balloon, this is the kind of like starting height. This is the end where the water balloon splats on the ground. This over here is going to be like the maximum height that the water balloon gets. I'm going to go ahead and label this. This is the max height. If you can see this, this is kind of a U shape. Anyone remember what we call the U shape graphs in math? Parabolas. Yeah, parabolas. Those are the quadratics, which are x squared graphs, which is why it has an x squared in the equation. So today we're going to be dealing specifically with the x squared graphs. So that means over here we have a y-intercept, over here we have an x-intercept, and right here, that maximum height, that's actually the vertex of the graph. If this is a U-shaped graph, then this is the vertex. So these are all things that we've found before. And then the nice thing about it is, since we're using Desmos to find all of our answers today, we just get to click on the graph and it's going to tell us what the answers are. Okay, so let's go ahead and let's get this plugged into Desmos. So I'm going to get Desmos pulled up. And I'm going to type in negative 4.9 x squared plus 27x plus 2.4. And don't mess with your window yet. I'm going to show you guys how we can figure out how to like make the perfect window on Desmos. And it's not going to be by like zooming in and out with your fingers. So before we zoom in and out with our fingers, what we're going to do is we're going to go up here to the gear. We're going to click on the table. Now, negative time, because x values are our time, negative time doesn't make sense. You're not going to go back in time to before you launched the balloon. So we're going to ignore -1, -2. We don't care about that. I do care about 0 seconds, 1 second, 2 seconds. I can see this is the pumpkin, or not the pumpkin, this is the water balloon being in the air. So it's 2.4 meters in the air. It's 24.5 meters in the air. It's 36.8 meters in the air. I'm going to click after the 2. And I'm going to press enter a few more times. So it's 39 meters in the air. It's 32 meters in the air. So I can see the water balloon has gone up in the air and now it's coming back down. So 14.9 meters in the air, now -12. So if I look at my Y values, I can see the water balloon went up and then it came back down. So this is my goal anytime I make a table. I want to watch the water balloon and the numbers. I want to see it go up, come back down. And then that tells me how big I should make my screen. So now I know that the biggest number over here is 39. So I'm going to go over here to my tool. And I'm going to change my Y value over here to something bigger than 39. Maybe 40, 45, 50. I'm going to change mine to 50. And then what just happened is I made a perfect window that I didn't do by zooming out. Okay, I'm going to show you the difference though. I want to show you guys what happens if I do it not that way, if I do it just by zooming with my fingers. So I'm going to put it back to normal. If I zoom with my fingers, do you guys see the difference? That's not as good of a picture, is it? So if we do it, I'm going to go back to normal. I'm going to click the toolbox. I'm not going to change my X values at all because my X values made sense. I'm going to change my Y value only, and I'm going to change it to 50. Now this is a good screen. Make sense? Okay, and we're going to do that every time. So now I've got all these different values, and let's go through and we're going to answer the questions one by one. All right, so the first question says, what is the initial height? Yes. So the initial height, yes. And when they say, what is the initial height, we want to figure out what they're asking for. So the initial height, that's a Y value. They're asking for a Y value, which means they gave us an X value, right? And what X value did you figure out that they gave you? Not that, that's not the X value though. The X value is 0. Because what does the word initial mean? Starting. What's the starting height? So we can look at the graph and we can say the starting height is the initial height. That's what you get when you were looking and you see 0. 0, 2.4. So we have the point 0, 2.4. The y coordinate is the answer. So the initial height of the balloon is 2.4 meters. So if the y coordinate is the answer, meters are going to be the units that I use in my answer. The initial height of the balloon is 2.4 meters. Okay, next question. How high is the balloon after 1 second? If they said how high, is that a time question or a height question? That's a height question. They want to know a y value, which means they must have given us an x value. What x value did they give us? They said x equals 1. So I'm going to look at the table and I'm going to see what the y value is when the x value is 1. X is 1, y is 24.5. X is 1, y is 24.5. That means that 24.5 is the answer. The balloon is 24.5 meters high after 1 second. The balloon is 24.5 meters high after 1 second. Wait until we're done with this. Okay, the next question says, for how long? Is that a time question or a height question? That's a time question. That means we need an x value to be the answer. That means they gave us a y value in the problem. What y value did they give us? 30. They want the y coordinates to be 30 exactly. So we're going to go back to Desmos. And I want to see. Yeah, okay. So we can't see right now 30 exactly on the table, which means we have to tell the calculator to tell us where the y coordinate is 30 exactly. So I'm going to go down here and I'm going to type y equal 30. Tell me where it equals 30 exactly. And then I can go and I can click right here it equals 30 exactly, and right here it equals 30 exactly. Does that make sense? So now I'm going to write it down. For how long is the balloon more than 30 meters high? I'm going to write down the two places where it equals 30 exactly, 1.356 and 4.154. So I'm writing down the two spots where it equals 30 exactly. Now the question said, for how long is the balloon more than 30 meters high? So if they said, when is the balloon 30 meters high? I would say the balloon is 30 meters high at 1.356 seconds and 4.154 seconds. I'd have my answer, but that's not what they asked. They asked, for how long is the balloon more than 30 seconds high in the air? So the balloon starts, it starts right here, right? The balloon is launched and the balloon goes up. And then this is where it starts being 30 seconds high. And then the balloon is just more than 30 meters in the air. It's 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 coming down, but it's more than 30 meters in the air. It's more than 30 meters in the air. Here's where it's exactly 30 meters in the air again. And then it's less than 30 meters in the air. So we need to know how much time has passed from here to here. what should we do? We should subtract the 2 times. So we're going to take 4.154 and we're going to subtract 1.356. And that will tell us how much time passed from when it started to be 30 meters in the air to when it finished being 30 meters in the air. So I'm going to do 4.154 minus 1.356. So the answer is 2.798. And we're going to do a really good job of showing what we did in our notes. So there's an X value, there's an X value. I'm going to show that I did 4.154 minus 1.356. And this is the answer that I got. The balloon is more than 30 meters high for 2.798 seconds. Wait till we're done with the notes. The next question says, what is the maximum height? What is the maximum height? Is that a X value question or a Y value question? That's a Y value question. That's a height question. Okay, what is the maximum height? So we're going to go back to Desmos. Where should I look on the graph? The max, the very highest point of the graph. So there's two places that Desmos helps us to find answers. One is through the table with the points, and then the other is by going back up to this equation, which will let you see the gray dots. Okay, so this is the points where I plug in 0, plug in 1, plug in 2, the other back to the original equation with the gray dots. The maximum is not part of the table. The maximum is part of the gray dots. The gray dots will give you the vertex, the maximums, the minimums, the x-intercepts, and the y-intercepts. That's what the original equation will give you. So here, it's only going to give me the y-coordinates if I plug in the specific x-coordinates that are a whole number. So you can see that there is a dot right here, but does everyone see how it's not quite the maximum? It's a little bit too far to the right. Does everyone see that? It's a little bit far off. So to get the actual maximum, I have to go back to the original equation. I just have to click here so that Desmos will let those gray dots pop up, and then I can click on the maximum. And it will tell me what the maximum is. So I'm going to go ahead and write down that point, 2.755 and 39.594. And I know that the y-coordinate is the answer. Now, sometimes they'll ask this question and they'll ask it twice. They'll say like, what was the maximum height of the balloon? And then they'll say something like, when did the balloon reach that maximum height? And so they'll ask you the question in a way where you have to answer first with the y coordinate, then with the x coordinate. So it's possible that you might need both coordinates to answer the question. So here they said, what is the maximum height of the balloon? That's a y coordinate question. The maximum height of the balloon is 39.594 meters. Okay. Next question says when. Is that an X or a Y value? It's an X value. When is a time question. When? So when will the balloon burst as it hits the ground? Okay, I'm going to go back to Desmos. All right. If we're looking for where the balloon hits the ground, what are we actually looking for? We're looking for the x-intercept. Yeah, we're looking for the 0. So I'm going to click here. I need those gray points to show up, and I need this gray point over here. Not this one. This one's before the balloon was even launched. I need this one over here. So the balloon is hitting the ground at 5.598 seconds. So I wrote that point down. Okay. Last question says when. Is that an X or a Y coordinate question? X, it's a time question. When is the balloon 27 meters high? So what did they give us? Yeah, they gave us, you were right the first time, they gave us a Y value of 27. Okay, so if they gave us a Y value of 27, what do we have to do? We got to do Y equals 27. So I'm going to where I had Y equals 30. I'm going to delete that, put 27 instead. And this time they didn't say when is the, or they didn't say for how long is the balloon more than 30 meters high. This time they just said when is the balloon 27 meters high. So here I just have to say what those exact answers are and I'm done. So the balloon is 27 meters high in 2 different spots. So I'm going to have 2 different times. And I'm using my X coordinates. So I'm going to say the balloon is 27 meters high. After 1.152 seconds and 4.358 seconds. So really today is all about where do I click on the graph? That's all you're doing today. Just clicking on the graph somewhere. The most annoying part is writing the sentence. Once you're done with that sentence, go ahead and turn the page. We're going to do another set of problems for a new context. Okay. So this one says we have pumpkins this time with large catapults and air cannons. The pumpkins are being launched. So here we have a new equation, very similar situation. So this time we're gonna have a little pumpkin. Does that look like a pumpkin? Kind of. It goes up in the air, comes down. So again, this is going to be how much time has passed. This is going to be the height of the pumpkin in the air. Just like before, Desmos only lets us plug stuff in terms of X and Y. So this is going to be our Y coordinate. These are going to be X's. So we're going to have Y equals negative 16x squared plus 120x plus 8. The X value is going to be our time. The y value is going to be our height. The height is feet. This time, not meters. The time is seconds still. Okay, so I'm going to go back to Desmos because I want to get this window figured out so that I can see everything I want to see. So I'm going to click the home button, go back to normal. And then I'm going to type this in. -16x squared plus 120x plus 8. And remember, we didn't mess with it with our fingers because if we try to zoom in, that looks really terrible. Everyone see that? That looks terrible if I try to zoom in, zoom out with my fingers. So instead, what do? I'm going to look at the table. I don't look at the negative values because for a story problem, negative values don't make a lot of sense, right? So what do? I'm going to click after the 2. And what am I looking for? I want the pumpkin to go up in the air. It's going up and now it's coming back down. And I'm looking for the pumpkin to become negative. I want the pumpkin to hit the ground. That's what I'm looking for. Go up in the air, come back down, hit the ground. So between 7 seconds and 8 seconds is when the pumpkin hits the ground. And now what am I looking for with the numbers? To see how big I should make my window. What am I looking for? I just want to see what the biggest number is so that I can choose a number that's bigger than that. So what's the biggest number you guys see on the table right now? Yeah, 232. So I'm going to go over here to the wrench. I want the y value to be bigger than 232. So maybe 250, 260, 275, something like that. I tend to like my numbers to be a little bit bigger, maybe 300. There we go. So just so I can see everything real nice. There we go. And once you plug in a number like that, if you want to zoom in or out, that would be fine. Now it's not going to be weird and skinny and stuff and hard to see. Okay, so first question says, what is the initial height? What is the initial height? So is that an x value question or a y value question? It's a y value question. And what is the x value going to be? 0. So we're looking for what is the y coordinate when the x coordinate is 0. So x coordinate is 0. What's the y coordinate? 8. Okay. So now we'll write our sentence. The initial height of the pumpkin is 8 feet. All right. Next question. What was the height? X question or Y question? It's a Y question. So what X value did they give you? They gave us 4. Okay. So let's look at the table. Let's see what the Y value is when the X value is 4. If X equals 4, Y equals, what's the table say? X equals 4, Y equals 232. Okay. I'm gonna go ahead and write my sentence. So after 4 seconds, the height of the pumpkin is 232 feet off the ground. Okay. Find the max height. X value or Y value? Find the max height. Y, height is a Y, okay. Find the max height. They didn't give us an X value to plug in, so that means it's going to be somewhere we can just click on. Okay, what do I look for max height? The maximum, the mountaintop. This isn't quite it, so I'm going to click right here, look for my gray dots. There's my maximum gray dot. Okay, so I'm going to write down my X coordinate and my Y coordinate because the next question actually uses another piece of information. So answer this question. The maximum height of the pumpkin is 233 feet. After how many seconds? Is that an X value question or a Y value question? That's an X, that's a time question. After how many seconds did the pumpkin reach its max height? Yeah, it's 3.75. It's the exact same point. They're just using the X coordinate this time. The pumpkin reached its max height. After 3.75 seconds. Okay. Next question says when? X or a Y value question? X. When did the pumpkin hit the ground? What are they looking for? X-intercept. So the pumpkin goes up in the air, comes down, hits the ground. We're looking for this X-intercept right here. So I'm not getting this from the table because that's not a perfectly whole X value, that's a decimal. So I'm making sure that I'm clicking where the equation is right here. So my gray dots show up, and then I'm clicking on the X-intercept right there. So 7.566. Next question says, how long? How long is an X? How long was the pumpkin in the air? So what did the pumpkin do? How long was the pumpkin in the air? The pumpkin was launched, went up in the air, came down. It's the same answer. So number 11 and number 12 are two different ways of asking for the exact same answer. When did the pumpkin hit the ground? That's an X-intercept. How long was the pumpkin in the air? That's an X-intercept. Same thing. It's the same question, asking it two different ways. So number 12 is the exact same answer as number 11. When did the pumpkin hit the ground? After 7.566 seconds. How long was the pumpkin in the air? It was in the air 7.566 seconds. That's how long it took. Next question says when. That's an X value. When was the pumpkin at a height of 95 feet? So that if they're asking for an X, that means they gave us a Y is 95. So what do we do? Yeah, we're going to go to Desmos. We're going to type in Y equals 95. So I'm going to go in here, type in Y equals 95. Okay. Y is 95 in 2 spots, 1 spot right over here, 1 spot right over here. So 0.813, 6.687. The very last question says how long? How long is an X question? How long was the pumpkin more than 110 feet in the air? So what Y value are they asking us to use? 110. So we're going to go back over here. We're going to plug in 110. We're just going to see right there, right there. 0.977, 6.523. Now, the question says, how long was the pumpkin more than 110 feet in the air? So we know this is where it starts, being 110 feet, right? And then we have all this time where it's more than 110 feet in the air. It's 160 feet in the air. It's 170. It's 180. It's 190. It's 200 feet in the air. It's over 110 feet in the air. And then it comes back down. And then this is where it's exactly 110 feet in the air again. And then it's less than 110 feet in the air. So what do we do with those 2 times? We subtract them. So we have the time when it starts being 110 feet in the air. We have the time where it stops being 110 feet in the air. We're going to subtract them. And that's going to tell us how long it was 110 feet in the air. .546 is exactly right. All right, so here's what I want you to do for tomorrow. I want you to graph this on Desmos, and I want you to do number 1, number 2. You guys can do those two. Number 1 and number 2. You have to graph it in Desmos. You have to find the maximum height of the pumpkin and see how many seconds it took to reach the maximum height. So when you graph it on Desmos, what are you going to find? The maximum, right? The maximum height is at the maximum. So you're really just going to have to worry about graphing this. Typing this on Desmos, making it so it's something you can see, finding the maximum. Okay, so you guys are looking at the very first problem, doing 1 and 2. That homework is going to take you less than 5 minutes. Okay, 1 and 2.